So this is our f of g of x that we calculated in the previous video. So now we have to find g of f of x. And this is g, and our f of x is x plus 3 over 2x minus 1. So this is the interpretation of this. When we say g circle f of x, we start from right, we go to the left. So we write the one on the left as it is, and the one on the right after circle, we replace it with the real function. And what happens here is that we take this and we substitute in g. So what is our g? Our g is x plus 3. I'm going to use a box to mean x plus 3, and then this is 2 times box minus 3. So this one, we are going to replace it here. This one, we are going to put it here. We are going to put the whole of this here, and the whole of this, we are going to put it here. And then we start doing the simplifications. So this will be x plus 3 over 2x minus 1 plus 3. All over 2 times, and this is x plus 3 all over 2x minus 1 minus 3. So this is our function that is numerator and denominator. Where there is x in g, we replace with this. Where there is x in the denominator, we replace with this. Now let's do the simplification, and then we get back to this one and substitute back. So let's take the numerator first. So the numerator, we want to simplify the numerator. So that will be x plus 3 all over 2x minus 1 plus 3 over 1. That is the numerator. And then we look for the lowest common denominator. If you have a term or an expression that has got variables and one that is numeric, to get the lowest common denominator, you multiply the 2. So this will be 2x minus 1. And then 2x minus 1 into this, it goes once. This is x plus 3 plus 1 into this is 2x minus 1 times this, which is 3 times 2x minus 1. So we move on, remove the brackets. So this is x plus 3 plus 3 times 2x, which is 6x minus 3 all over 2x minus 1. X plus 6x is 7x. 3 minus 3 is 0. So this is all over 2x minus 1. So this is the numerator after simplifying it. And then here we are going to simplify the denominator. So we take this one here, denominator. So this will be twice x plus 3 all over 2x minus 1 minus 3. This is over 1. Like we explained earlier in the second video, when we have a numeral or a scalar quantity outside brackets, this is multiplying this fraction. When we have a scalar or a quantity, a term outside the bracket, and it is multiplying a fraction, that whole number or that numeral, it will only multiply the numerator. So this is 2 times x, 2x, 2 times 3 plus 6 all over 2x minus 1 minus 3 over 1. We look for the LCM, the lowest common multiple of these, or the lowest common denominator in this case, which is 2x minus 1. 2x minus 1 into this goes once. 1 times this is 2x plus 6 minus 1 into this, it goes this times 3 is 3 outside, and then we've got 2x minus 1. So we now remove the brackets, collect like terms. So this will be 2x plus 6 minus 3 times this is minus 6x minus 3 times minus is plus 3 all over 2x minus 1. Right, subtract 2x minus 6x is minus 4x. When you subtract a big number from a small number, the answer is always negative. You do the ordinary multiplication and then you attach the negative sign as your final answer. 6 plus 3, not 6 minus. This minus is not in any way attached to this 3. It's only attached to this one. So it's 6 plus 3, that will be plus 9 all over 2x minus 1. So this is our denominator simplified. This is a simplified denominator, which means that in the numerator, we put this one. In the denominator, we put this one, because it's simplified. So this will be 7x all over 2x minus 1. This long bar here, horizontal bar, means division. So we use the division sign, the symbol division, over this. This is minus 4x plus 9 over 2x minus 1. So this one here, it will be 7x over 2x minus 1 times 2x minus 1 over minus 4x plus 9. Cancels out, and then you remain with 7x all over minus 4x plus 9. So this is what you remain with, and this is what f of g is. So this will be g of f of x. G composite f. This is f composite g. So f composite, in conclusion, f circle g of x is not equal to g circle f of x. Therefore, f and g are not inverses of each other. The function f and function g are not inverses of one another. So that is the conclusion that we draw. So when you are given this type of problem, you cannot find the inverse of f and then find the inverse of g and then make conclusion there. You have to find the composition of this function. Find f composite of g, find g composite of f. The answers that you get, you compare them. If they are the same, then you conclude that the two functions are inverses of one another. If they are different, then the two functions are not inverses of one another. So this is basically what we are expected to do in as far as this type of problems is concerned. Thank you. As we meet to the next video.